Hello everyone, today I'll be teaching you about the basics of trigonometry. Trigonometry is the study of the ratios of sides of triangles, where trig means triangles and metry means measurements. Now, let's take this triangle as an example. A right-angled triangle is a triangle that has a 90 degrees, a 90 degrees angle. So we have here a right angle, which equals to 90 degrees. Now, so we already have some lengths to the sides, so we can solve for next stuff. So with that being said, let's learn a little bit of trigonometry. There's three core functions of trigonometry. There's sine function, there's cosine law, there's cosine function, I will say law, I don't know why, and there's the tangent function. Before that, let me write something that will help you remember sine, cosine, and tangent. I'll be writing SOHCAHTOA. You're probably saying, what's SOHCAHTOA? Now I'm gonna tell you in a bit. So means that sine equals to opposite over hypotenuse. Opposite over hypotenuse. And the cosine and the ka means that cosine equals to adjacent over hypotenuse. So adjacent over hypotenuse. And finally, the TOA means that tangent equals to tangent equals to opposite over adjacent. Opposite over adjacent. Now let's take an example so I'll make you understand better. So let's move on. Now let's take this triangle as an example. Let's choose this angle and call it theta. And we'll be solving for sine, cosine, and tangent. So we'll be finding sine theta. We'll be finding sine theta, cosine theta, and tangent theta. So sine theta equals, as we said in the SOHCAHTOA, sine equals to opposite over hypotenuse. And the cosine equals to adjacent over hypotenuse. And finally, the tangent equal to TOA, which is opposite over adjacent. Now for sine equals the opposite of the angle theta, which is 3, 3 sine theta equals 3 over the hypotenuse, which is 5. And the cosine of theta, cosine theta equals to adjacent over hypotenuse, which adjacent over hypotenuse. So adjacent is 4 and the hypotenuse is 5. So cosine theta equals 4 over 5. And finally, tangent equals opposite over adjacent. So tangent theta equals opposite, which is 3, over the adjacent, which is 4. So tangent theta equals 3 over 4. On the next slide, I will be choosing another angle, and we'll be solving for sine, cosine, and tangent. Let's move on to the next slide. For this example, we took the same triangle but different angle. So we took this angle, which is labeled as x, and we'll be solving for sine, cosine, and tangent. Now remember, the opposite and the adjacent are different now, because the angle is different. So the opposite will be this one, which is 4, and the adjacent will be 3. Now let's solve for sine, cosine, and tangent. So let me write sine x, cosine x, and tangent x. So sine equals to opposite over hypotenuse, and cosine equals to adjacent over hypotenuse, and finally the tangent equals to opposite over adjacent. Now, so sine x equals to the opposite over hypotenuse. The opposite now is 4. So sine x. Oops, sorry. X is kind of weird. Sine x equals to the opposite, which is 4, over the hypotenuse, which is 5. As I said, the hypotenuse is always the same. It does not change. Now cosine equals to adjacent over hypotenuse. So the adjacent is 3. So cosine x equals to the adjacent, which is 3, over the hypotenuse, which is 5. So cosine x is 3 over 5. And finally, tangent x. So tangent x equals to the opposite, which is 4, over the adjacent, which is 3 right here. So we have sine x equal 4 over 5, cosine x equals 3 over 5, and finally tangent x equals 4 over 3. Thank you for listening. I will see you next time. Bye.